Okay, here we go, preparing for Learning Target number 2 quiz. So I'm going to start with basic, level 1. I can estimate the rate of change of a graph at a point by sketching a tangent to the graph. So here is the graph, it's already given to us. I want to find sketch a tangent, sorry, let me just read the question. Sketch a tangent to find the rate of change of f of x when x equals 4. So when x equals 4, 1, 2, 3, 4, I go up and I put a point on the graph right there. So at that point, 4, 2, it looks like, I want to sketch a tangent. So a tangent just touches, and I sketch that in. There it is. There's my tangent. And then I want to know what is the rate of change. Rate of change is slope. So looking at that, I just drew a horizontal line, so that means that the rate of change is 0. So the derivative of f of x when x equals 4 is equal to 0. So the slope of my tangent line at x equals 4 is 0. The slope is 0. Okay. Now the next one, sketch a tangent to find the rate of change when x is 2. So I'm going to go to 2, 1, 2. Oh, I'm already there. That's on the parabola. I want to draw in my tangent. So I'm just eyeballing it. And I'm looking for some good intersections. I don't seem to have really good ones, but that's okay. We're just going to estimate, right? So there, and close enough. We'll take that. So what is it approximately? It's up 4 over 2. So that would be 4 over 2, which is equal to approximately 2. Okay? If you got something a little bit different, that's fine. The first time that I did this, I actually got 7 over 3. I think I had a longer straight edge, and so I was able to make a better tangent because I had a longer straight edge. The straight edge is kind of short, so I don't know. I think I did it like that when I did it before. If I do it like that, and then I'm going from here up and over, that would be 1, 2, 3, 4, 5, 6, 7 over 3. So something like 4 over 2, or if you got 7 over 3, it's just something close. Okay, so you got to show to me that you can draw a tangent and that you can find the slope straight off the graph. All right, the last one, when x equals 7, 5, 6, 7, right there. Again, we're going to draw in our tangent. And I'll draw that in. Do I have any good intersections? Not really. Let's see if I keep going. I had a longer. Oh, that looks pretty good. So I'm going to use that one. And where else am I kind of close? Wow, these are terrible. So I'm looking for somewhere that I'm close to an intersection. Maybe this one. Kind of close there. Let's go ahead with that one. So that's over 3, and this 1, 2, 3, 4, 5, 6, 7, 8. So it looks like I'm 8 over 3, and notice I'm decreasing. It's going down, so that would be negative 8 over 3. Okay, so anything close to that, as long as I can see how you did it on your graph, that you've got the idea of drawing in a tangent, and you've got the idea of finding the slope. Okay, that's the approximate rate of change at that point right there. We're doing it by just eyeballing the graph. All right, that's our basic. Okay, next, level 2, I can use the derivative function using, I can find the derivative function using the first principles formula. Sorry about that typo there. All right, so now we got to do the work. So I'm going to get another piece of paper. By the way, this is official IB paper. Ooh, pretty cool. Graph paper. Papier, whatever. Okay, different languages. All right, so I'm going to go ahead and copy this over here. This is level 2, letter A. F of x is equal to x squared minus 3x. I need to find the derivative, but I have to use the first principles formula. Okay, so our first principles formula is the limit as h approaches 0 of f of x plus h minus f of x, all divided by h, or x plus h minus x, which simplifies just to h. So the first thing I need to do is find f of x plus h. So f of x plus h, I'm going to plug into my x's, my x plus h. So I get x plus h squared minus 3 times x plus h. If I expand this, x plus h times x plus h, and then I'm going to distribute that, minus 3x minus 3h, don't forget to distribute the negative. And now I'm going to go ahead and multiply this out. I'm going to get x squared plus 2xh plus h squared minus 3x minus 3h. So this is my f of x plus h. That's it. Nothing else I can combine there. Now I'm going to put that into my formula. So I have the limit as h approaches 0 of x squared plus 2xh plus h squared minus 3x minus 3h minus all of this again, x squared minus 3x, all divided by h. All right, I'm going to go ahead and rewrite this part. I'm going to distribute my negative. So negative times positive is negative, negative times a negative is positive. So this is going to change. X squared plus 2xh plus h squared minus 3x minus 3h minus x squared plus 3x, all divided by h. Let's see what I can eliminate here. X squared minus x squared, negative 3x plus 3x, and it looks like that's it. So the limit as h approaches 0 of 2xh plus h squared minus 3h, all divided by h. I can now factorize that. I bring out my h, I'm left with 2x plus h minus 3. I can reduce my h's. I have 2x plus h minus 3. Now I can just substitute in 0 for my h, and I'm left with 2x plus 0 minus 3, which gives me 2x minus 3. So f prime of x is equal to 2x minus 3. And now that we know the shortcuts, we can actually go back and make sure we got it right, because we do know our shortcuts. So our shortcut, if we go back to the original problem, is I take the exponent and multiply it by the coefficient in front. So I get 2x, and I subtract 1 from the exponent. So I get 2x to the first. Okay, so if I was just doing this by shortcuts, 2 comes out in front, minus 1 from the exponent, so I just have x to the first. And then this one, the invisible exponent is a 1. 1 times negative 3 is negative 3. 1 minus 1 is 0, so the x just goes away. I'd get 2x minus 3. So the shortcut says 2x minus 3, and when I did it the long way, I also got 2x minus 3. So yeah, sorry. Now that you know the shortcuts, you're probably going, oh my God, why are you making us do this? Because I want to know that you can. All right, 2b, or not 2b. Okay, 2b, I have y equals 5 minus 3x, and I want to find dy dx. Okay, let's do it with the shortcut first. The shortcut, well, 5 doesn't have a variable, doesn't have an x, so that just goes to 0. And the other one, the invisible exponent is a 1, so 1 times negative 3 is negative 3, and the 1 minus 1 is 0, so the x just goes away. So I know this is the answer by using the shortcut, but now we need to use the formula. So again, the formula is the limit as h goes to 0 of f of x plus h minus f of x, all divided by h. Okay, so again, I need to find f of x plus h. That's the hardest part. So where my x is, I'm going to replace it with x plus h. So I have 5 minus 3 times x plus h. If I simplify that, I get 5 minus 3x minus 3h. That's f of x plus h. Now I'm going to put it into the formula. So I have the limit as h goes to 0 of 5 minus 3x minus 3h minus the original function, 5 minus 3x, all divided by h. And if I simplify that, I get the limit as h approaches 0 of 5 minus 3x minus 3h minus 5 plus 3x, all divided by h. And, oops, I'm off the side, there it is. Now 5 minus 5 is 0, negative 3x plus 3x is 0. I'm left with a limit as h approaches 0 of negative 3h, oh, that's it, over h. I can reduce out the h's. H divided by h is 1. So I'm left with the limit of negative 3 as h goes to 0. Well, there is no h, so nothing to substitute in, so I'm just left with negative 3. And that is what I got when I did my shortcuts. So I know I did it right. Right? So my derivative, dy dx, is equal to negative 3. And remember, this is how we write the derivative. We don't do f prime of x if we're given the equation in y equals form, because this is change of y over change of x. Whereas if we're giving it in f of x form, since we don't have an x, we don't have a y here, we just say y prime. Right, there it is. All right, number 3. Problem number 3, I can find the derivative, again, using first principles. So we're given f of x is equal to, oh, f of t, different variables, but that's okay. T is just the same as x, except we're using a t because it's talking about time, minus 4.8, that would be meters per second squared. All right, this is the acceleration of gravity. All right, so what have we got? We want to find the derivative of this, again, using first principles. So I'm going to do f of t plus h, just like we did before was x plus h, but now since they're giving us t instead of x, I'm going to find f of t plus h. So 452 minus 4.8 parentheses t plus h squared. Let's expand that. I'm going to get t squared plus 2th plus h squared. I can distribute that. 452 minus 4.8 t squared minus 4.8 times 2. I am not letting you use a calculator. Oh my gosh, 4.8 times 2. Well, let's see, 48 plus 48 is 96. So that'd be negative 9.6 th minus 4.8 h squared. Okay, can I combine anything? Nope. So now I'm going to do my limit as h approaches 0 of 452 minus 4.8 t squared minus 9.6 th minus 4.8 h squared, all divided by h. Let's see, what can I cancel out? Oh, I forgot. Not ready to cancel out yet. Now I need to minus the original function, 452 minus 4.8 t squared, and limit as h approaches 0. Let's simplify that. 4.8 t squared minus 9.6 th minus 4.8 h squared minus 452 minus a negative gives me plus 4.8 t squared, all divided by h. Now let's see what we can cancel out. 452 minus 452, gone. Negative 4.8 t squared, positive 4.8 t squared, gone. And I'm just left with these two terms. So I have the limit as h goes to 0 of negative 9.6 th minus 4.8 h squared, over h, factorize that, bring out my h, negative 9.6t minus 4.8h, and cross out my h's, and so I'm left with the limit as h approaches 0 of negative 9.6t minus 4.8h, so that h is going to become a 0, so negative 9.6t minus 4.8 times 0, I'm left with negative 9.6t, and that is my f prime of t. Bam. And I could check that using the shortcuts. If I look at the shortcuts, 452 would just go to 0. 2 times negative 4.8 is negative 9.6. And then minus 1 from the exponent. Bam. I know I did it right. Okay, so that was part A. Oops, running out of paper. Yeah, running out of paper. So B, hence find the speed of the jumper when t equals 2. Oh, I don't need much room for that. So for question B, find the speed of the jumper. I'm going to just go ahead and do it back on here. Now that I have my derivative, f prime of t is equal to negative 9.6t. So all I have to do is plug in 2 for the t. So that's going to give me f prime of 2. It's going to be equal to negative 9.6 times 2, which is equal to 2 times 6 is 12, carry my 1, 18, 19, and it's going to be negative 19.2, and that would be, that's the speed, so that would be meters. Is this given in meters? Yes, meters per second. The other way of writing, oops, where am I? There I am. The other way of writing meters per second is to write meters second to the negative 1. Okay, you'll see that a lot probably in your physics classes, and you sometimes see that in IB as well. Meters per second or meters per second, because the negative 1 means it goes on the bottom of the fraction. All right, when is the jumper traveling at negative 11.52 meters per second? See, there it is. I wrote the meters per second the other way there. Okay, so there, I need to set my equation equal to 11.52. You know what? I think maybe I am going to let you use a calculator on this. I just realized that's kind of an ugly answer. Okay, I changed my mind. You get to use a calculator on this quiz. All right, so I'm going to do negative 9.6t. I want to know when does it equal negative 11.52. Oops, let's move that to the side. So all I got to do is divide by negative 9.6, negative 9.6, and I get t is equal to, at what time does this happen? I don't know. I don't have my calculator handy. Help. I need a calculator. Calculator. I forgot that I was going to need a calculator for this. So no cell phones, by the way. So make sure you do bring a calculator, preferably your graphing calculator, to school with you for the quiz. So I'm going to put in 11.52 divided by 9.6, and I get 1.2. Negative divided by negative is positive 1.2 seconds. There's the answer to C, 1.2 seconds. All right, that is level 3. And then level 4 we worked on in class already. Remember how I had you write your explanation, then I had you go around and talk to 2 other people about their explanation, and then you rewrote your explanation again and you shared it with a 3rd person, and that's it. I'm not giving you any more help on that one. So if you still can't explain the derivation of the derivative function, where this comes from, what it means, and we're talking about its slope, it tells us the slope of a function. If you can't explain that by what we've done so far in class, I recommend doing some additional research. Get on Google, get on YouTube, and listen to other people explain it, okay? Because I've done what I can. Good luck. See you Friday.